My name is Samantha, and this is my AP Calc BC video project. This is on the 2014 FRQ, and it's problem number 5. And I hope you enjoy this video. So this problem says, let R be the shaded region bounded by y equals x times e to the x squared, y equals negative 2x, and the vertical line at x equals 1. And part A says, find the area of R. So first we need to figure out our bounds, which is fairly easy from the picture that they provide. Because x equals 1 is one of the lines that bound the region, we know that 1 is going to be one of our bounds, and the other one is going to be the origin, because that's where they meet in the picture, and if you plug in 0 to each function, you'll see that they both get 0 too. So our bounds are from 0 to 1. Now the principle of finding an area under a curve is that you take the bigger curve minus the smaller curve, so whichever one's higher. Because the bottom one is a straight line, we can see that y equals negative 2x is going to be the smaller one. So we take the integral from b to a, or 0 to 1, and then subtract negative 2x from x times e to the x squared, which will turn out to be x times e to the x squared plus 2x, because a negative minus a negative equals a positive. We can't use a calculator for this problem, so we're going to have to integrate manually. 2x is easy to integrate, it's just x squared. But the other one, we have to do a little bit of u substitution. So if we make x squared, the exponent, into our u, and we take the derivative of that, it's going to be 2x dx. So when we plug that in, and we substitute in dx for du divided by 2x, we can cancel out the x's, and we get 1/2 times the integral of e to the u. We integrate that, and we plug it in, and we get 1/2 times e to the x squared. So now we can plug in our values and find the area. So 1/2 times e to the x squared plus x squared, which is the integral of 2x, and then we plug in 1, and then we subtract that whole thing once we plug in 0. So we get 1/2 e to the 1 plus 1 minus 1/2 e to the 0, which is 1/2, plus 0. So after all that, we get 1/2 e plus 1/2, or as the scoring guidelines put it, e plus 1 over 2. The second problem, part B, says, write but do not evaluate an integral expression of the solid generated when r is rotated about the horizontal line y equals negative 2. Revolutions between two curves are pretty similar to finding the area between two curves, in that you subtract the smaller one, or in this case the one closer to the axis of revolution, from the one that's farther away, or the so-called bigger one. The formula for that is pi times the integral of the farther one squared minus the closer one squared. The thing that's sort of hard about this problem is the shift. It's not being revolved around y equals 0 or the x-axis. It's being revolved around y equals negative 2. So it's actually pretty simple. You can think of it like, how do we shift it up so that y equals negative 2 becomes y equals 0? All we do is add 2. But the important thing to remember is, because this is not a cross-section, we're taking one thing and subtracting it from another thing. We're not finding the radius between two things, and that's going to be the base. So we need to add 2 to each one, and not just at the end. So how we do that is just down there. Because the farther one from y equals negative 2 is x times e to the x squared, we have to add 2 to that one, and square all that, and then subtract negative 2x plus 2 squared. And that's how you set up your integral. And the bounds stay the same, because it's still the same functions. Yeah. The last part, part C, says, write but do not evaluate an expression involving one or more integrals that gives the perimeter of R. So one thing to remember before we go into this is that everything is going to be positive. It doesn't matter if a value is negative. What matters is the distance between two things. So now going on to the problem, we have pretty much 3 parts in the perimeter of R. We have the one given by y equals x times e to the x squared, y equals negative 2x, and x equals 1. So for y equals x times e to the x squared, this is not a straight line, so we're going to need to use the arc length formula, which is the integral of a to b of the square root of 1 plus the derivative of the function squared dx. So let's go into part 1, which is the arc length of y equals x times e to the x squared. So we find the derivative of that using the multiplication formula, which is seen there. So we take x times the derivative of e to the x squared, which is 2x e to the x squared, and then we add ex squared times the derivative of x, which is just 1. So after all that, we can simplify and factor out e to the x squared, and we get e to the x squared times 2x squared plus 1. So we can plug that into our formula, and that's what we get down there. The integral of 0 to 1 times the square root of 1 plus the derivative of x times e to the x squared squared. Going on to part 2, which is the distance from 0 to 1 of y equals negative 2x. We can use the Pythagorean theorem here because because y equals negative 2x makes a right triangle with the x-axis and with x equals 1. This is also just the distance formula. So because it starts at the origin, we can just use the Pythagorean theorem. So let's call side A the distance from 0 to 1, which is obviously just 1. Part B can be the distance between 1, 0, and wherever y equals negative 2x intersects with x equals 1, which turns out to be negative 2. So negative 2 minus 0 equals 2. It also doesn't matter because we're squaring it. So we do 1 squared plus 2 squared equals c squared. We get c squared equals 5, and then c comes out to be the square root of 5. So this is just a constant. We don't need an integral for this. Part 3, which is the segment of x equals 1 between y equals x times e to the x squared and y equals negative 2x. So we need to find out at what y value x equals 1 intersects with those two functions. So we just plug x equals 1 into each function. So y equals x times e to the x squared comes out to be just e, and y equals negative 2x comes out to be negative 2. So remember, it doesn't matter that it's negative. It's just a distance, so we're going to do e plus 2 because that's the distance between those 2 points. And then putting it all together, we just add all those 3 values up. So we get the square root of 5 plus e plus 2 plus the integral of 0 to 1 times that whole arc length formula. And that's how you do part C. That's the end of my video. If you want to practice other problems like this, I would recommend looking in the book. For problems about the area between two curves, you can go to section 6.1 in numbers 5 through 18. For problems about volume by revolution, you can go to section 6.2 to problems number 12 through 14 and number 19 through 30. And for arc length, you can go to section 8.1 and for problems number 7 through 18, excuse me. Thank you for watching.